Applications of differentiation. In this video, we are going to continue with tangents and normals. We are going to look at a more complicated example, and this is the kind of example that you will find in the examination. You will find this on page 272 in the Namibian AS-Level Mathematics textbook, y equals mx plus c to success. The equation of a curve is this, and the equation of a line is this. One of the point of intersections is this. Find the angle between the straight line and the tangent to the curve at P. Give your answer in degrees correct to 1 decimal place. Now, if we want to differentiate this curve, we must first make y the subject of the formula. How do we do that? We divide by x on both sides. Then remember, x cannot be in the denominator, so take it to the numerator. Now you can differentiate. And if you differentiate, you will get negative 1 times 12, so it's negative 12x, and negative 1 minus 1, and that will be negative 2. And now you can bring it down. So differentiate, and this is the derivative function. Now, first find the equation of the tangent. Now, I just want to say, in this example, they don't specify that you must find the equation of the tangent. And I think I will change this to make a that I asked you, like I'm going to show you in the try now, to first find the equation and then to find the angle. So actually, in this case, it was not necessary to find the equation of the tangent. This part was not necessary. Okay, but I must find the gradient at the point 2. So in the differentiated equation, I substitute 2 and the gradient will be negative 3. Okay, now if I take this straight line and I want to see what's the gradient, also make y the subject of the formula. So if I take x over, it will become negative 2x plus 10. So what is the gradient here? Here the gradient will be negative 2. So this is the gradient of the curve, and this is the gradient of the straight line. Okay, now this is very important, this information. So I want to just recall it a little bit from previous work. So the gradient of a slope is also defined as, now remember tan. Tan is what? It's opposite there, tan theta is opposite over adjacent. So it's actually the difference in y over the difference in x. Okay, so bring in your trigonometry knowledge. So if I'm going to say where theta is the angle of the, meaning the angle makes the positive direction of the x-axis. Now remember, in trigonometry, we will say this is 0 and this will be positive rotation. So if I'm just having the gradient and I want to find out the angle towards the x-axis, now just take note. If it's negative, the gradient, then the line will be like this. So then look there. That will be the angle towards the x-axis. Okay. Now, I want you also to remember, can you still remember your cast diagram? Think back of trigonometry. So, this is my cast. Now, if I think of tan, where is tan positive? No, in this case, where is tan negative? Remember, we don't press the negative in. Now, tan is positive there. So tan will be negative there, and tan will be negative there. Okay, so if I, now remember, a triangle is only from 0 degrees to 180. So basically, I'm blocking this one out. Okay. So I'm just working with this one if it's negative. So if, remember, don't press the negative in, press on your calculator, shift, tan, and then press 3. That's telling your calculator. I just want to get my calculator. And then equals. And that will give me, so shift, tan, 3 equals. That will give me 71.5 approximate to 2 decimal places, 5, 7. So basically it's 180 minus that, because remember, how do I find that angle? That 71.57 is this angle, so, but I want the blue angle, so it's 180 minus that 71.57, and that will give me an answer of 108.43. Okay, leave it 2 decimal places because the final answer must be 1 decimal place. Now, I also must find that was the angle towards the x-axis of the curve. Now the straight line, it's still negative, so it's exactly the same. Just press now Shift tan 2. Shift tan 2, and that will give me 63.4349, but 63.43. And then, now don't forget, okay, let me just get another color. It's again blue. Okay, I want this angle. This angle will be that 63.43. Okay, now if I want, I just subtract 180 minus, and I'm getting this. Now don't forget, I'm looking, find the angle between the straight line and the tangent. So I'm sitting now with the different values. Okay, let's take, I just want to show you. Okay, here is my x-axis. Now say for example, the one line was like this. Okay, and the other line was like this. Now just see green, blue, okay. Oh, I don't want to take yellow. What will I? Red, doesn't matter. The other line was like this. Now, which one? Remember, the angle works from there. So if this one was, say the green one was 108, that is 108.43. And this red one was 116.57. But I'm looking for this angle, the angle between these lines. So I'm just going to take this 116.57 and I subtract the 108.43, and that gives me an angle of 8.1. And that's my final answer. Okay. I want you to stop the video and I want you to do the following numbers. Let's just go to the next page. I want you to do number 1 and number 2. Remember, this is the way that you will find it in a Cambridge type of examination, as well as in the new AS-Level of Namibian mathematics question papers. Okay. You can continue the video as soon as you are finished. But let's start. Number A. A curve has the equation of the curve. Find the equation of the tangent. Now, this is how I'm going to rephrase that example, 15, because it's done like this. Actually, it was not necessary if it was not break up into an A and a B. Okay, but let's start. A curve has an equation. This is number 1. And what is my function? And P is the point on the curve. Find the equation of the tangent to the curve at P. Now, first get the equation ready to differentiate. Remember, we don't want the variable in the denominator. We bring it up as a bracket. And then it's -1. And now we can follow the chain rule. So it's going to be y equals 4u to the power -1. And u is equal to 3x minus 4. And then I differentiate dy du equals -4u to the power of -2. And du over dx equals 3. And then dy over dx equals -12. I multiply and I can just bring u down. And if I fill it in, it's -12. And in the place of u, what am I going to write in the place of u? I'm just going to substitute u back. So it's 3x minus 4, and it's going to be a square. Okay, now we're going to start. The gradient of the tangent where x is 2. So we're going to say, let's just take another color, gradient of the tangent where x is 2. Okay, so basically it's just going to be then dy dx, just do it like that, and just substitute, or the gradient, it's negative 12, and I'll substitute the 2 in the place of x, and then you square, and that is negative 12. 6 minus 4, so it's going to be 2 squared, it's 4, so the gradient is going to be negative 3. Okay, now they want the equation. Remember, I'm busy with number A. So the equation of the tangent at 2, okay. So basically, use your formula. It's y minus y1 equals mx minus x1. Okay, and let's just write it down. This is x1, y1, and this is m. So if I substitute it, it's y minus 2 is equal to m. I forgot to put m. M is negative 3 x minus 2. And if I simplify this, minus 2 is equal to negative 3x plus 6. So y is equal to negative 3x plus 8. It becomes positive 2. Okay, that is the equation of that tangent. Now find the angle this tangent makes to the x-axis. Now if I'm just going to find this is going to make to the x-axis, so I'm just going to say I'm working with this. So I'm just going to bring in my tan. Let's just take it in red. So tan theta, and that is negative 3. And don't forget, it's in your cost. Tan is negative there because it's just 0 to 180. This one is blocked out. And now I just find first my key angle, or my reference angle. And how do I do that? I press Shift tan 3 equals, and I get, and make it 2 decimal places, 71.57. So to get theta, it's 180 minus 71.57, and that is 180 minus 71.57, and that will give me an answer of 108.4 degrees. And that is the angle, the positive angle that it makes with the x-axis. Okay, that was number 1. Let's do number 2. Okay, number 2. The diagram shows the curve. Okay, again my function. Now just remember your chain rule. Very, very important. As soon as it looks a little bit complicated, use the chain rule. So again, I'm just going to take it first out of the root. We don't want it in the root notation. And that is going to give me a half. So I'm going to say y is equal to u to the power of half, and u is equal to 3x plus 1. So dy over du is equal to a half u minus a half So it's 1 over 2u. And du over dx equals 3. So dy over dx equals 3 over 2. And put the u back, and that is 3x plus 1. Okay, that is my formula after it is differentiated. Okay, now I'm going to start. Now, if I'm going to say the diagram points at 0 and 2. Now, let's first get the angle at the point P. Okay, so let's just going to say gradient first. First the gradient. The gradient, before we come to the angle, the gradient of the tangent where and x is 0. First x is 0. That will be actually as indicated P. So I just substitute. So it's just going to be the gradient. Let's call it MP. And that will be 3, 2, 3, 0, plus 1. And that is 3 over, this is just 2. And that is the gradient, 3 over 2. Now, I'm going to find the other gradient also. The gradient of the tangent where x is 1. And that will be at the point Q. So, let's call it MQ. And now we just substitute 1. And that is 2 times, it's 4. So it's 3/4. Okay, now I'm going to come to my angles. Let's just move it up. Let's get to the, now I'm going to say the angle of inclination is towards the x-axis. Inclination of tangent at P. At P, so it's going to be then tan theta equals 3 over 2. Okay, now just remember this is going to be positive. So in this case, it's just going to be there. So I can just say shift tan bracket 3 divide 2. And that is just going to be 56. So remember, so theta, it's now not in the second quadrant, it's in the first one. So 56.31. So I'm going to move up. Back to green. The angle, now it's again this green one. Angle of inclination of tangent at Q. So it's going to be theta, and now it's a 3/4. So shift tan bracket 3 divide 4 close the bracket equals, now this is going to be 36. So theta, and remember it's positive, so it's again in the first quadrant, because remember, I just want to recall this, it's the cast diagram. So where is tan positive? Because it's now both positive, the ratio. So it's there and there. This is blocked out because it's just from 0 to 180. So that will be 36 36.87 degrees. So I'm coming to the finals. Therefore, the angle between the two tangents will be this 56.31 minus 36.87, and that will give me an answer of 19.4 degrees. That will be the angle. Try number 3. It's a very good example to practice, and you can look in the teacher's guide. You will find the workout solution, and at the back of the textbook you will just find the answer.